Do you understand why this diagram shows that A is 4, 3, the vector 4, 3?
Um, is it because it goes? I'm not sure.
Well, what were you going to guess? What were you going to suggest?
I think one of them, 4 is up and 3 is down. I'm not sure.
Well, let's check. Check where A starts, check where A finishes, count how many it goes across, how many it goes up.
Oh, it goes across 4 and up 3.
Yeah, it goes across 4 and up 3. So we know the top number is for numbers in the horizontal direction, and the bottom number is numbers in the vertical direction. Cool. And then for B, do you get why it says 1, 3?
It goes. Wait, on the graph it says minus.
It does say minus B. So what do
So
you think?
um, it goes to the left by 1 and down by 3.
Okay. In that case, then, if that's the case, what is the vector of minus B then?
-1, -3.
Perfect, yeah. -1, -3. So first of all, the direction matters. So a vector has two components. It's got magnitude, or if you like the size, or how far, or how much of something you're doing, and it's got direction as well. And the plus and minus really do matter.
Okay.
Right, there's another thing that we can think about as well. So if we're going from this blue dot that I'm marking to this blue dot that I'm marking, like you just using your own knowledge about vectors and how they work, what would be a vector that takes us from this blue dot to another blue dot?
3, 0.
Yeah. So to get from that blue dot to that blue dot, we can see it's the vector 3, 0. Right, but notice how it also says, they've also described that same vector as A minus B. So let's calculate what A minus B is actually going to be. How do we work out what A minus B is?
Do we just do the minus the vectors by each other?
Yep, perfect. So we've got 4, 3 minus 1, 3. And what does that give us?
3, 0.
3, 0 indeed. So what are our findings from this? What do we notice?
I'm not sure.
Well, compare the thing that we've just added compared to when I asked you to work out the vector.
You just minus it like normal numbers, or like normal numbers.
Well, there's that, yes. But also notice how A minus B got us an answer of 3, 0. But when you just looked at it, that was also 3, 0. Same answers.
Yeah.
So this is no accident, and this part is what forms the fundamentals basically of looking at the problems that we're going to look at next in vectors. So to
Okay.
get from the first blue dot to the second blue dot, you could go straight across the black line, which is A minus B.
Yeah.
Because they've given us the vectors for A minus B. But you can also travel along the red path of A. So along here. And you can also then travel along here. And as far as vectors are concerned, it's exactly the same journey because it gets you, the start point and the end point are exactly the same.
Wait, how?
Well, okay, so look at A minus B.
Yeah,
A took us through the vector 4 minus, 4, 3.
yeah.
Then minus B took us through minus 1, 3.
Okay.
And when we combine those vectors, our overall vector was 3, 0.
Yeah.
And that's the same thing as just going straight across the black path. So the point being, pardon the pun, you start from the blue point on the left in the grid,
Yeah.
we end up on the blue point on the right on the grid. And with vectors, it doesn't matter what path you take, as long as you start in one place and you end up in the other place.
Okay.
Cool. So that being said, then, now what we're going to do is we're going to work out different things. So, next page. We're going to take this very slowly and we're just going to be creative as such. So at this stage, we're not looking at what exam questions say per se. We're just going to be looking at understanding components of vectors. So I'm just going to give you about 30 seconds to have a read of this and just digest the diagram, and then I will start asking questions and talking and doing all of that stuff. Okay, so that's about time. Right, so that being said, then, with this diagram, we've got like parallelograms, and they've also told us that B is the midpoint of OG. So really what we're saying is these parallelograms, the three parallelograms are all identical parallelograms, essentially.
Mm.
So let's look at a few things. We've been told the vector from O to A, capital A, is given by the little a, and O to B is given by B. Let me ask you a question. What would the vector A to E be represented by?
Would it be A as well?
Yes, it would be A as well, seeing that it's parallel to OA, and the A is the midpoint of OE. Okay. What about, so let me just mark down the diagram as well. What about E to D?
B
Yep. And then are there any other vectors that you can tell me?
is B to C one.
Yeah. What is that?
A.
Yep. What else?
Mm. C to D.
Mm-hmm.
Is that A?
Yeah. Any others?
Is B to G one?
Yeah.
B. Um. G to F.
G to
F.
oh G to F. Yep.
A
Mm-hmm.
and C to F.
Yep. What is C to F?
A B.
Nice. And what about A to C?
Oh, a B.
Cool. Okay. Here's another question. What is D to E?
Um, will it be minus
Minus what?
B?
Yes, indeed. So anytime you go in the opposite direction to the way in which a vector is labeled in terms of its arrow, it's always
Yes.
going to be minus.
Okay.
And that's one very important thing with the whole direction factor. Okay, that's good. So that's one thing. Here's another question. What is vector O to E?
Can you do like algebra?
So what are you thinking of doing?
2A.
Indeed, yeah. Because O to E is A plus A. A plus the A. So indeed it's 2A. Okay. Just going to put C to D is also A. Now the next question that we want to ask ourselves is this next one. It's a funky one. Now, how we want to work out what D to F is. So what's the initial problem that we have with going from D to F?
Is not parallel to. Is it not parallel to any of the other lines?
Yeah, it's neither parallel to A nor parallel to B. So it's a bit hard to now determine this in terms of A, or is it? This is where we use the fact that, remember, it doesn't matter how we get from D to F as long as we start at D and we finish at F. So what alternative pathway could we take if we want to start at D and finish at F?
A minus B.
Nearly. It's
Minus
actually
A minus B.
not minus A minus B. It's minus
Minus,
A plus B.
okay.
Because to go from D to C, you're going against the arrow for A, so it's minus A. And then to go from C to F, you're going with the arrow
Okay.
to B. The D to F is going to be minus A plus B. Another way you can write it is B minus A. It's the same
Okay.
thing. Does that make sense?
Yeah.
Cool. All right. Um, that being said, then, so again, I'm gonna repeat this. I'm probably gonna say this like at least 5 times. It does not matter how you get from one letter to another. Doesn't matter what path you take, as long as you start at the first letter and you end at the second letter. You can take the wackiest path and it's the same result.
Okay.
So I want to go from O to F.
2B
Yep.
plus is that A?
Yep. Perfect. So you're going along this path and then along this path. That's going to be, yes, as you said, 2B plus A. Equally, you could have gone along this path and like that. A plus 2B is the same thing. Okay. What about from E to G?
Mm, minus 2A minus 2B
Say it one more time.
minus 2A minus 2B.
Okay, so which way did you go first of all?
I went from E to A to O to B
Okay,
into
so you
G.
went down this way. So are you going with the arrow or against the arrow?
Oh, is it plus 2B?
Okay, yep. So going from E to O, you're going against the arrow. So indeed, that's going to be minus 2a. And then as you go from O to G, you're going with the arrow, so that's plus. So minus 2a plus 2b, or you can say 2b minus 2a. Sometimes there might be instances where it's necessary to factorize. You could even say 2 open bracket b minus a, and you factorize out that bracket. Is it making sense so far?
Yeah.
Okay, good stuff.
Is B to H? Wait, can that be a line?
Mm-hmm. Yeah, indeed.
B.
Yeah, it is.
And so then A to G would be A.
Yep.
Um, is B to C A?
B to C.
Or C to B?
Okay, so what is B to C?
A.
You're starting at B and you're finishing at C. Are you going with the arrow or against the arrow?
O minus A.
Minus A, yeah. That is so important. In fact, I think for today's lesson, we'll probably even just focus on looking at different diagrams and just understanding, yeah, just getting used to plus, minus, and combining vectors. So
Okay.
C to B, yes, we can put an arrow like that. And indeed, that's going to be A. But B to C, different ball game. So yeah.
Um. So D to C would be B.
Yes. D to C is indeed B.
With E to D, it doesn't. Would it be zero or something?
For what, sorry?
E to D, it doesn't move. It's not going up or down. Or
Well, okay. So E to D seems difficult to work out right now because it's not in the same direction as either A or B. It's neither in the same direction as A nor B. So let's instead have a look at A to B for some motivation. So how can we get from A to B?
it just goes straight.
From A to B?
Yeah.
But what vector is that though? Remember, it doesn't matter how we get there. It just matters that we start at A and finish at B. So we've got to go along a path that we actually know.
Mm, do you have to go the whole way around or to O?
Well, not necessarily the whole way around,
A to
But
O
yeah, A to O, and then
to B.
yes. So what's that going to be?
Minus A plus B.
Nice. Yes, because you're going from A to O, which is against the arrow, and then from O to B, which is with the arrow. Good stuff. So yeah, minus A plus B, or indeed B minus A. Okay, so if AB is equal to minus A plus B or B minus A, then what would ED have to be?
B minus A.
Yeah, it's the same thing because it's parallel, isn't it?
Yeah.
Okay. From that information, what would D to E be?
Minus B plus A.
Yes, perfect, because you're reversing everything. Yeah, minus B plus A or A minus B, however you want to say it.
Mm-hmm.
Good stuff. Okay, let's take this a little bit further. So we know, in fact, I'm not even going to say anything. What is uh K to L going to be?
Um. Mm, uh. Would it be 2B minus 2A?
For K to L?
Okay. Oh. I thought you said J. 2B. 2A.
Very good, 2A. Because K to L, we see, well, hopefully we see is parallel to E to F, which is again parallel to OA. And we know that the triangle, the hexagon, um, which KL is contained in, is enlarged by scale factor 2. So that's 2A. Cool. Okay, so uh, what's next? Okay, since you got excited by doing that one, let's do K to J because you had some good ideas there. So what's KJ?
I said 2B minus 2A.
Yeah, 2B minus 2A because we can see that is two lots of ED because they're parallel, and the hexagon which contains ED is enlarged by a scale factor of 2 to give you the hexagon which contains KJ. So yeah, it's going to be two lots of B minus A, which is equal to 2B minus 2A. Good stuff. Good stuff indeed. Okay. What about to get from L to J? L to J.
2B.
What's that?
2B.
From L to J?
Oh, minus 2A. Wait.
So you're going this way, yeah?
Um. mm, uh. Can it be minus? Wait. Uh. Can it be 2B minus 3A?
Uh, okay, so how do you get that?
Because oh, because L is L to K is going the opposite way of A, So B minus, and that's a third A. So I'm not sure.
Okay, so to get from L, how are we getting from L to K? First of all? What's the vector that takes us from L to K? This one here.
Minus A.
Sure. Definitely minus. It's something to do with minus A. Pay attention to the size of this.
Minus 2A.
Right, minus 2A. Okay.
Mm-hmm.
But then we also need to go from K, because now we're at K, and we need to get to J. So what's the vector for K to J?
Minus. Mm, it's just plus 2B.
Sorry?
Is it plus 2B?
To get from K to J?
Oh, 2B minus 2A.
Right, so we need to add the vector 2B minus 2A. So in terms of simplifying that, how do we?
So it'll be 2B, and then your minus 2 from 2. That'll be minus 4.
Yep, 2B minus 4A. There we go.
Okay.
So that's how that's working. Again, I'm just going to keep giving you diagrams, so it's not drawn accurately. So we've got slide 4. So I'm just going to let you digest this a little bit. Okay, so you've read and looked at the diagram. What vectors can you determine?
I wasn't really sure about this one.
Okay. Well, okay, what vectors? We can see certain vectors. Let me ask you then.
You can see that A to B is 4B.
Mm-hmm.
O to A is 2A.
Mm-hmm.
And O to C is 8B.
Mm-hmm. What about if you wanted to go from, say, O to B?
2A plus 4B.
That's it. Look, with that being said, can you think about some other vectors that you might know? Does that make sense?
Uh, yeah.
Yeah, cool. All right, so I'll let you think about some vectors that you might know.
Could A to C be 4B minus 2A?
From A to C,
B to C.
from B to C.
Yeah.
What path did you take?
The around from
Nice,
B to A to O, then to C.
nice. That sounds good. So yeah, from B to A, you've got the vector minus 4B, and then from A to O, you've
Yeah.
got
Plus 2A. I
so
mean minus 2A.
yes, minus 2A, and then from O to C, you've got plus 8B, and then we can simplify that with 4B minus 2A. Good stuff.
I'm not sure.
Well, you've done B to C, maybe A to C.
Um 4B. Would it be 8B minus 2A?
Yes, because you're going from A to O, which is minus 2A, and then O to C, which is plus 8B. Yeah, or you can say 8B minus 2A. Cool. Are there any other vectors that are worth working out? Actually, yeah, this one might be a good one. If A to C is 8B minus 2A, what would A to E be?
Pardon?
AE. So I've written it down.
Oh, wait, would that be 8b minus 2a as well?
Well, it doesn't take. Does it start at the
Oh,
same
wait.
and
Sorry,
as AC?
never mind. Yeah, I'm not sure.
Okay, so what do you notice about how does AE compare with AC?
Oh, is it halfway?
Why? How do you know that?
Because it looks like it's.
What information in the question can you see?
Oh, E is the midpoint of A, C.
That's it. So E is the midpoint. So now you know that A to E is halfway.
So 4b minus A.
So what you say again, sorry?
4b minus A.
Yes. Very good, because it's just going to be half of AC. So A to E in relation to AC is half of AC, which in this case is going to be 4B minus 1A or just A. Good stuff. Okay. So similar question. What's BD going to be?
Uh, 2b minus A.
Very good, because it's half of BC, and BC we already worked out. And that's going to be 2B minus A. Cool. Okay. Here's one. What about if you wanted to go from O to E?
Would that be 4b um hmm, minus A?
Say that again.
4b minus A.
To get from O to E.
I think
So what path did you take?
I went O to A to E.
Okay, so O to A is
2A.
right, and A to E is
4b minus A.
yeah. So plus 4B minus A. What does that simplify to?
Oh, 4b minus A.
No, not 4B minus A.
Um,
Well, what does this simplify to? So you've got 2A minus A, which is,
wait, it's 2A minus A, not A.
yeah, it is A.
Oh, plus A.
Plus A, yes, not minus A.
Oh, okay.
So A plus 4B, or your version, but just a bit refined, 4B plus A. Hey. Yeah, you did well. Well done.